Hello everyone. Today we'll be again continuing with our discussion on binomial theorem. Today we'll be doing a topic which is known as basically the middle term of a binomial expansion. So let me write down the topic for you. So the topic that we'll be doing is basically the middle term in the expansion, middle term in the expansion of x plus a whole to the power n. So we'll be looking for the middle term in the expansion of x plus a whole to the power n. Now this middle term of x plus a whole to the power n, it depends on one criteria, whether n is odd or n is even. Now if n is even, so if n is even, so basically if n is even, so how many terms are there in a binomial expansion? Suppose we have x plus a whole to the power n, so how many terms will be there in that expansion? We'll have basically n plus 1 terms. Now if n is even, then we have basically n plus 1 will be basically an odd number. So if n plus 1 is basically an odd number, then we'll have only one middle term. Because suppose if in a term you have if in an expansion you have 5 terms, so the middle term will be basically the third term, which is one. There is only one middle term which is existing. So that middle term is basically n by 2 by what can I say? If n is even over here, that will be n by 2 plus 1. So that will be, in this case, it will be, if n is even over here, then middle term is the n by 2 plus 1th term. So this is an important thing that you need to be very careful about, that if n is even, then the middle term is the n plus 1, n by 2 plus 1th term. So this is what you need to remember. Now what happens if n is an odd number? Suppose n is equal to 3, then what is happening? So if n is equal to 3, suppose you take the expansion of 1 plus x whole to the power 3, then you have 1 plus x cube plus 3x square plus 3x. So there are 4 terms in total, and you have 2 middle terms. The second term and the third term are the middle term. So in this case, if n is odd, then you have 2 middle terms. So what are those 2 middle terms? The first middle term will be the n plus 1 by 2th term and n plus 3th by 2th term. So these are the terms which will be the middle terms in the expansion of x plus a whole to the power n in case n is odd. So this is the thing that you need to remember. Suppose, as I took the example, if 1 plus x whole to the power 3. So here in this case n is equal to 3. So we are getting basically the second term and the third term will be the middle term. So let's check it out. So if we put n equal to 3 over here, so we have 3 plus 1, that will be 4, 4 by 2, that will be equal to 2. So one of them is correct. And then we have, if we put again 3 over here, then 3 plus 3, that will be 6, and 6 divided by 2, that will be equal to 3. So we have, so that is verified over here. So as you can see, if n is odd, n is even, then we have the n plus 2 plus 1th term, and you have n is odd, and you have 2 middle terms, n plus 1 by 2th and n plus 3 by 12th term. So these are the 2 things that we need to care about. So let me do a sum on it. Let me do a simple sum on it so that it's more clear to you that how you need to proceed with the problem. Let me rub it out. Let us try to find out the middle term of this expansion. Suppose 1 plus x to the power twice n, and we need to find out the middle term. So this is what we need to find out. So as you can see here, the power is how much? Power, as you can see here, it is power is twice n. So what will be the middle term in this case? So the middle term will be basically, here n is an even term. Basically, first thing we need to write is twice n is an even number. So we have only one middle term in this case, and that will be twice n by 2 plus 1th term. So that will be basically twice n by 2, that will be n plus 1th term. So what is the n plus 1th term? N plus 1th term we can denote it as capital T with the suffix of n plus 1. So this denotes the n plus 1th term. So in this case, T n plus 1 will be basically equal to twice n Cn into x to the power twice n minus n. So this is the formula. So this will be equal to twice n factorial by n factorial into x to the power n. So this is basically the structure. So now if we expand it, so this will give us 1, 2, 3, and this will go on up till twice n minus 2, then we have twice n minus 1 up till twice n, and then we have n factorial by n factorial in the bottom portion, and also we have this multiplied into x to the power n. So this is the structure that we're looking forward to. So now if we take out all the even terms and all the odd terms, we multiply it together, we separate it and multiply it. So this will give us rise to the structure of 1, 3, 5, and this will go on up till twice n minus 1. So this is one structure. Into, if we take 2 into 4 into 6, and this will go on up till twice n. And then we have n factorial by n factorial in the bottom, and this is entirely multiplied by x to the power n. So this is the structure. So now one thing that is very interesting to note in the even part is that if we take 2 common from each of these terms over here, so how many terms do we have in this structure? We have n terms over here. So basically we have to take out 2 n times. So if 2 is taken out n times, that will give us rise to a structure of 2 to the power n. And if we take 2 common from the first one, it will be 1. Then 2 into 2, if we take 2, then here it will be 2, 3, and so on up till n. So this is basically 1 into 2 into 3 up till n into 2 to the power n. So and then 1 into 2 into 3 up to n, that can be written as n factorial. So this n factorial in the bottom and in the top will cancel out, and we will be left with 2 to the power n in the numerator. So this will give us to rise to the structure of 1 into 3 into 5 up till twice n minus 1 by n factorial into 2 to the power n into x to the power n. So this is finally the middle term that we are looking for f1 plus x whole to the power twice n. This is the middle term over here. So I hope that your concept regarding the middle term of a binomial expansion is very much clear. In case you have any doubt, then you can comment in the comment section below, and we'll try to get back to you. Thank you very much.